Assalamu alaikum warahmatullah. So, as you know, last time we made a discussion on some problems which were purely based on what I can say the conservation of mechanical energy and the work kinetic energy theorem. Today I will discuss one more problem based on the same stuff, and so then after I will just go to and comment on the one more term, that's what we can say the power. But before discussing the power here, it's moment to discuss one more problem based on the conservation of mechanical energy and the work kinetic energy theorem. That's what basically problem is here. If I will just mention here, if in a given problem it's given like we have the kind of what I can say the frictionless path. Okay, I'm just, if the path as it is shown here, it's frictionless. Okay, it's a smooth path. In a way, if my particle is here at the top, okay, relative to this, but if this represents the bottom point of the given path, okay, my box is here of mass m, and when it moves, okay, it just moves in this way. Okay, if this is my hair, this, if I will just, if it confuses to you, I will just make my path so that it seems to you the, is it really possible for us that the box, it will just move. Okay, if this is my box here, it's somewhere at the top of this frictionless path, and it is at a height of h relative to this point of reference. If I will take my this as a reference in order to calculate, and the potential energy of this particle, okay, in a region of gravity, if this is my gravity field here, okay, now if it's given in a problem, the circle we are just talking about, more specifically it's a vertical circle here. Okay, so every radius has some, every circle has some radius, let it be r here. Okay, the moment when it just move along this path, the path I'm just talking about here, it's smooth path, means it's a frictionless and no frictional force will encounter here. It's a force of gravity here, the force of gravity only here, that will take a part, and we know that gravity force is a conservative force. Under this step, my mechanical energy will be conserved. Okay, this is something that we have discussed in the post-op lectures and all that, but here it's a moment to look and calculate what should be the minimum value of this h. If I'm assuming that when my h will be h minimum, how much its value will be, so that particle during its motion, as long as it stays with this frictionless path, because the normal force is a type of contact force that will develop here, and because of that it will just stay with this. Okay, as a result it will just complete my here the vertical circle. Okay, for that what should be the minimum value of this height here? Okay, so if I will just remind to you, if the particle during its motion it is going to move along in a vertical circle, okay, so what's the condition? That condition is known as, it is something, if we'll use the conservation of mechanical energy, we can find out this stuff here, but there's no need. I'm just directly going to use this result here. It's a requirement for a particle motion when it moves along a vertical circle. So if this condition for the velocity of a particle during its motion will be satisfied, so I can safely say, then after my particle will just move in a vertical circle, it will complete the vertical circle. Okay, this is the the condition for particle to complete the vertical circle. So this is a result that I will use here. So for that I will use the lower limit of the velocity. So velocity of the particle, it should be at least under root of 5 gr, otherwise it must be greater than this. But under both the conditions, if I will use either this or this, so this is equality condition. If I'll hold it here, so this is enough to say that my particle, it will just cover, complete the vertical circle during its motion. Okay, if this is my vertical circle here, the radius r, so that its velocity should be under root of 5 gr. So it is something that I will use here, but before using it, I will just look to the problem. If I will analyze my problem here, my particle is somewhere sitting at the top of this rough surface, so that from this reference above, from this reference above, and the particle height is h. Okay, so its total energy will be in the form of potential energy. How much that will be? That will be mgh. Okay, now when my particle will reach here, let us assume that is my point B, where B is a representation of the bottommost point. Okay, it's a kind of reference point from we just measure the potential energies of this particle and all that. Okay, so at this point my velocity as this when this box it is supposed to move along this trajectory, when it reaches here it will have some velocity. How much that velocity will be? Okay, but here I can say more safely here my particle potential energy will be definitely zero, because this is my reference where I measure my particle potential energies and all that. Here the particle total energy, it will be in the form of what I can say the kinetic one. Okay, if I will use a definition of the kinetic energy of the particle, it is something we scale. Okay, the velocity of the particle at the bottommost point, let it be v. Okay, so these two energies must be equal, because it's the only gravity force which encounters here, and gravity force is an example of the conservative one. Under conservative force my total energy always conserves, so I can safely equate these two equations. I can write my EI is equal to EB. From that I will get my mgh will be equal to is 1/2 of mv square. V is the velocity of the particle at the point B. Okay, so hope you are getting it. If the things will cancel here, my velocity at the bottom point, it will be 2gh. Okay, this is something I got from using the conservation of mechanical energy and all that. Now if I will look this condition is meant for the particle motion that it complete the vertical circle. This is something which I told you as before. Okay, so I need to calculate basically here the minimum height. So calculate my minimum height. What I can do, I will use the lower limit of this velocity. Otherwise it's greater than this. My h will be minimum only because velocity is proportional to height here. Okay, under root of this. So h will be minimum here only if my velocity will be minimum. Minimum value of velocity is here. Yes, it will be v is equal to under root of 5gr. Otherwise it's greater than this. This is something the minimum value of the particle velocity, so that it can still complete the vertical circle, but at the same time this is the velocity at the bottommost point. I can equate these two equations, so I will get here 2gh will be equal to 5gr. Okay, if I will just cancel here, the things will cancel here like this way. My h, but it will be h minimum. Okay, it will be h minimum because the minimum value of the velocity, so it can settle, complete the vertical circle, that's 5gr. Otherwise it's greater than g, so I will use calculate here h minimum. Minimum value of h will be it will be 5/2 of r. Hope you are getting. Yes, here is 5, here is 2, here is r. Okay, this was the demand from the question. Here I got the minimum value of h. It is 5/2 of r, so that particle will complete the vertical circle. Okay, so this was all about this problem. It was all about this problem. Thank you.